Hi everyone, I am Vishwanath. I represent all the physics videos to you for class 12 students. If you like my videos, then please click the like button and please subscribe my channel. Today I am discussing about Gauss theorem and its application. Before going to the main discussion, at first we have to know about area vector, electric flux density and solid angle. At first I am giving you the definition of area vector. What is area vector? Area vector, when we consider an area capital A, and this may be circle, may be rectangle, may be square, or any type of two-dimensional figure, and we draw a straight line on the plane. This surface, two-dimensional surface, is closed by the line C, and its area is capital A. That means magnitude of the area is capital A. Now we draw a normal to the area, and this normal must be outward direction. Then this normal denotes the direction of area vector, and the magnitude of the normal is equivalent to the magnitude of area vector. If O and P is the area vector which is denoted by capital A, then area vector capital A is equal to OP. Okay. Now I am going to define electric flux. Electric flux. We consider this is an uniform electric field, and the parallel lines denotes the uniform lines of force of the uniform electric field, and the uniform electric field or electric field strength is denoted by capital E. Okay, where capital E is the electric field strength of this area or of this location. Now we place a plate or any two-dimensional figure, or we consider any two-dimensional figure whose area is capital A. That is, its area vector is denoted by capital A. Now, angle between the area vector and electric field is theta. Let capital E is the electric field at a point P. Capital A is the area vector of a surface bounded by the curve C. Bounded by the curve C. Okay. Let E is the electric field at a point P. Capital A is the area vector of a surface bounded by the curve C at that point P. Now, the electric flux at the point P is equal to the number of lines of force passing through the area in normal directions. That is, electric flux at P is electric flux at the point P is phi is equal to E vector dot A vector is equal to EA cos theta, where theta is the angle between E vector and A vector. Okay. The electric flux phi is equal to the number of lines of force passing through the surface in normal direction, whose area is capital A. Now, I am going to define solid angle. It's a very new concept for you. Solid angle. What is solid angle? Let us consider a surface closed by the boundary C, whose area is capital A. That is, its area vector is A. Okay. P is a point, P is a midpoint of the area. Now we consider another external point O. O is an external point of the surface A. OP is equal to R. That is, R is the position vector of P with respect to the point O. Now we can join the all points, on the boundary C. That is, we can join the all points which are situated on the boundary C. Okay. Therefore, we can get a 3D angle at the point O. This is denoted by omega. The omega is known as solid angle. Omega is known as solid angle. Solid angle of the area A at the point O is omega is equal to A dot r cap by r square. This is equal to A cos theta by r square. Okay. Omega is equal to A cos theta by r square. This is known as solid angle at the point O. In calculus, we can write solid angle is equal to d omega is equal to cos theta into dA by r square, where theta is the angle between r vector and a vector. We know the closed integration of a angle is equal to 2 pi. Then closed integration of d omega is equal to 4 pi. Okay. And the unit of the solid angle is stat radian or stat radian. Stat radian. Stat radian. Now I am coming to our main topic, that is Gauss theorem in electrostatics. Gauss theorem in electrostatics. Gauss theorem states that the total electric flux passing through the closed surface is equal to the 1 by epsilon 0 times of the charge confined in the closed surface. That is closed integration of E dot dA, where A is the surface area. In many books it can be denoted by ds. Okay, closed integration of E dot dA is equal to q by epsilon 0, where A denotes the area vector of a surface enclosed by a boundary C. Q is the net charge confined inside that surface. Epsilon, we know the epsilon 0 is the permittivity of the air or vacuum. Epsilon 0 is the permittivity of air or vacuum. This theorem is written in SI system. This theorem is written in SI system, and we conduct this experiment in air or vacuum. In SI system, in air or vacuum medium. Okay. Now we have to prove this theorem. To prove this theorem, we have to draw a surface enclosed by a boundary C, where A is the area vector, where P is the midpoint of the surface. Now O be a point outside the surface where a positive charge Q is placed at the point O. Now the charge Q emits electric lines of force. Okay, and dA is the area vector of the small portion. dA is the area vector of the small portion which is bounded by the curve small c, and the large portion is bounded by the curve capital C. Okay, and Q is the charge placed at the point O, and Q is enclosed by the boundary capital C, and capital A is the area of the large surface, and dA is the area of the small surface. In many books, the Gauss theorem is proved by a sphere, but this is a special case. But this proof is in general way, or this proof is can be applied in any surface. Okay, now we can draw a solid angle by joining the points which is situated on the curve of the small boundary C, and this solid angle is denoted by d omega. OP is equal to R. Theta is the angle between R and dA. Theta is the angle between R and dA. Let a plus Q charge is placed at the point O, which is bounded by a closed curve C, capital C. Capital A is the area of the large surface. dA vector is the area of the small surface produced by the boundary produced by the closed boundary boundary small c. Okay, and d omega is the solid angle produced at the point O by the area, small area dA. D omega is the solid angle produced by the area dA at the point O. Now, electric flux passing through the area dA is d phi is equal to E vector dot dA. Okay, where E vector is the electric field strength, electric field strength, or electric field, simply electric field at the point P due to the charge plus Q. Capital E vector is the electric field at the point P produced due to the charge plus Q. Okay, now we know that dE is equal to we know E vector is equal to how much? 1 by 4 pi epsilon 0 Q by R square into R cap. Therefore, d phi is equal to 1 by 4 pi epsilon 0 Q by R square R cap dot dA, which is equal to Q by 4 pi epsilon 0 dA cos theta by R square, because R cap dot dA vector is equal to dA cos theta, and we know that dA cos theta by R square is equal to d omega. Therefore, Q by 4 pi epsilon 0 into d omega, because dA cos theta by r square is equal to d omega. Therefore, the total flux passing through the surface capital A is total electric flux passing through the surface capital A, that is phi is equal to, therefore the total electric flux passing through the surface A is how much? Phi is equal to closed integration of q by 4 pi epsilon 0 into d omega. We know that q by 4 pi epsilon 0 is constant, therefore this equal to 4 by q by 4 pi epsilon 0 comes out from the integration, and we only integrate the d omega part, and we again know that closed integration of d omega is equal to 4 pi, therefore this is equal to q by epsilon 0, that is phi is equal to q by epsilon 0, which proves the Gauss theorem in electrostatics. Okay, but if the charge q is placed outside the point C, then what will be the result? The flux or result, the flux will be 0. That is, when q plus q is situated outside the surface A, or the outside the boundary which is closed by C, then the total electric flux passing through the surface equal to 0. Why? Because we can consider a solid angle okay, this is equal to omega. Now the electric flux or electric lines of force which is entering to the surface from q plus q in the solid angle omega, the number of lines of force enters to the surface is equal to number of electric lines of force comes out from the surface. Okay, therefore net electric flux is equal to 0. When plus q charge is placed at a point outside the surface outside the surface, then total number of electric flux or lines of force passing through by lines of force, electric flux or total number of lines of force passing through in normal direction, total number of electric flux enters to the surface is equal to the total number of electric flux comes out from that surface. Okay, therefore the resultant electric flux is equal to 0. Therefore the resultant electric flux phi is equal to 0. Okay, and again, if there will be there many charges, that is, if a surface contains more than one charges, then the charge q is equal to the algebraic sum of the charges. That is, if a surface contains q1, q2, q3, etc., and qn charges, then the resultant charge, net charge q is equal to q1 plus q2 plus dot 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 qn. This is the algebraic sum of the charges. I is equal to 1 to n. This is the Gauss proof of Gauss theorem. On the next session, I shall discuss about the applications of Gauss theorem. Now it is a time for end the discussion. Thank you for visiting my videos.